What's up, guys? Hello. We're back. Good evening, my fellow friends. Good evening, good evening. Right, we are back. We are back to studying. Yes, you heard that. We're back to studying. Okay. We're almost done actually. Pretty much everything else is just medium, advanced. I did a little bit of off-task studying, but I figured that I gotta give you guys an update. So, I actually found it to be of course, what would you expect? I found it a lot easier to study on my own rather than having to stream. But, yeah, but you guys are cool, so that's why I wanted to stream today. But, I do have about 6 hours of studying, and hopefully we can, get to it. Just make sure that everything's working properly. Okay? Alright, let's start with factoring quadratic and polynomial expressions. Okay, so I did learn grouping. That's pretty cool. So let's see. Let's start with this equation here. For some reason, I find these so much easier for some absolute reason. It's like the most oddest thing ever. Like I don't even know how I struggle with these other ones. But yeah. Anyways, I also wanted to show you guys these cool animations I made. It's a cool walk animation. Gotta shoot. Boom, boom, boom. You know, speaking of which, I should actually... Okay, don't save, I don't need to. I might redo my AKM shoot. I think I might just redo this. Let's go to the, let's make a new window here. Let's make this the graph editor. Let's do a little bit of this before we, before we study, of course. Okay, so let's remove all of these keyframes. No, I want to delete these keyframes. Hold on. Delete keyframes. There, we want to duplicate this. Let's do automatic snapping here. There we go. On the 4th frame, okay, let's do a frame right in here. Let's do it all channels. That's weird. Why is the right arm doing that? We can do that later. go back to here. Or actually, let me see my other animations. Let's do. I have a idle pose or idle animation here. It's 60 frames long. It's not too bad, right? Not too bad. Not too shabby, right? And then we got our gun shoot here. It's not terrible. Also have a gun shoot with camera shake, but it's not appearing because it's pose mode. Gun with camera shake. I hate Blender. Let's continue here. Okay, so let's find a pair value that multiplies to 24 and adds to 25, which is going to be 24 and 1. Okay, the greatest common factor is going to be 4x, which you can rewrite it as that. Cool. And then our other factor is 4x plus 1. Special factoring is only when there are perfect squares. Alright.
Let's see if we can factor the expression 45x.
Okay, so let's do this example here. Let's do this example. Let's do this board. I don't think I can draw on this actually. So let's just hop onto Canva. Okay. Okay, so what we're gonna do here first. Let's put this to black. Can I change the... There. that's a good size. Okay, anyways, let's make this a little bit bigger. I want to make sure this is on the top corner. This is on the side, and this is on the bottom. No, on the bottom, please. Okay, and then we're gonna put that there. There we go, organized. Okay, so let's do this one right here. Right, so let's get 4x squared plus 12x plus 9. We can factor out 3. No, not 3. No, we can't factor anything out. So let's actually do 36 and 12. And then we have to have it multiply to 36 and 12. So two factors I'm thinking of is 6 and 6. This is 6 times 6 and 6 plus 6. Right. So then we can do 4x squared plus 6x plus 6x plus 9. And then we can factor out the x on this one. On this one right here. And then we will get, factor out 2x. So we will get 2x times x plus 3 plus, and then we can factor out 3 here. So it will be x plus 3. And then we would factor this out to this. That will be our answer. It should be right. Something's not right. Oh, it's supposed to be 2x. 2x plus 3. And then x plus 3. And then we'll get 2x plus 3 times 2x plus 3 times x plus 3. That's weird. That shouldn't be right. Oh, right here. I factored it wrong, actually, so it'll be 2x plus 3. Okay, yeah. Alright, get it now? Cool. If you guys don't get it, make sure. Hello, Bob John. Okay, and then, so let's try and factor this one right here. Erase all that. Let's write down 9y power 4. But like, what if the SAT question was just to factor 9y 4 minus 25x squared? Like, what if you were just given this, right? I mean, you can't just plug in the Desmos and just tell it it's a factor. I don't think that's how it works. But like, I don't think they do factoring. Understand that, but like, it depends on the question, really, I think. Yeah, but like, what if the what is it? The x squared coefficient was not 1. What do you mean if it was a constant? What do you mean there's no constants? Oh, I see. Okay. I think those are variables. Junior? I refer to them as variables rather than constants. I think constants are like a little bit different. Pre-calc? Okay, well, I guess I'll have to refer to them as constants. They're the same thing, right? I don't want to get things confused. Could also mean these solutions. Okay, so if I was given this, what would I do? What would I do with it in Desmos? CT. Need the SAT version. Okay, so let's do that. Yeah, well, not a great result. Or f of x. Let's do f of x. Alright, well. That has to have a slider for y now. Go back to the question. It just tells us to factor it. I mean, like. This one right here. Let me just paste in the chat for you. Factor that. Yeah, like, bro. That's what I was wondering too. Like, can you, like, I don't think Desmos can factor this. I'd have to do this manually. Wait, there's a special factoring thing here. You serious?
Times 3x minus.
Yeah, well, that's what I'm doing, bro. I'm reviewing this stuff. I haven't done this in ages. I really had no use for it, too. That's why I don't bother to remember this stuff. Till now, of course. X minus 5. 3y minus... Is that right? I think that's it. Let me double check to make sure. No. Oh, sorry. Whoops. Whoops. Sorry. I miss. There we go. Small x's. Exponents. I think. Oh, it's squared. Right. Okay. Right. If you okay. Yeah, I got it now. Not this one. Not this one. I have to go back to the equation. Squared. Okay, so this one does only. This one doesn't have it. No, this one doesn't have it. The y does. Y has a squared. X. So this, if I'm right. Yeah. Cool. Okay. If x plus y is equal. Okay, let's erase this actually. Cool. All right. Actually, let me see if it's right. Yeah. There we go. We got that exact same answer. Okay. Cool. If x plus y. What happened? If x plus y is equal to 8 and x minus y is equal to 2, what is the value of x squared minus y squared times x squared minus 2xy plus y squared? It's the difference of squares. That means we can factor the expression into an x plus y, x minus y, x minus 2xy plus y squared. What can be factored into a square or difference or square difference. Special factoring to evaluate an expression. Might need an explanation for this. I didn't get much sleep last night, so my brain's not working as well. But I have the most time today out of the next couple days. Today is the day where I have the most amount of time to study. So I'm gonna have to make sure I fit all of that in. Difference of squares. I think I got that. Yeah. X. Okay, can be factored to square of difference or x minus y squared. Okay. Oh, I forgot these two are squared as well. Okay, we can just plug. Oh, okay, that's cool. Okay, so what is ax is equal to ax plus 11, bx minus 2, a and b are constants. What is the value of a minus b? Wait, so it's just 8x plus 11 times negative 5x. Is that right? Negative 5x. A and b are constants. Minus 2. Is that right? Yeah, no, that doesn't look right. That doesn't look right. That's what I thought. Okay, so what do they do up here? We have to be able to factor in the A and B. Oh, I see. Okay. So we just factor it normally, right? Yeah, I think we just factor it normally. Let me. So much easier to do this on paper, actually. I'm assuming you guys have paper. I don't have to do it on this whiteboard. Let's do that real quick. Okay, so we got 16 and 11 for thingies. So we'll get 8x squared. Minus 16x plus 11x minus 22. Unless there's like a more complex subject that you want to talk about, I think I'll be able to do this on my own, to be honest. Unless you think that there's something that I don't understand that you really need to teach me, then I'm willing to do that. But unless it's okay, plus 11x minus 2. It's 2. Okay, factored it out completely. Oh, I got it. Nice. Alright. Okay, it's gonna be 8 minus b is gonna be 7. Pretty sure. Should be 7. Yay. Okay, which of the following is equivalent? Well, if any of you guys are watching out there and don't understand, I can explain this to you if you need. Which of the following is equivalent to 4x squared plus 28x plus 49? Okay, so let's factor this out completely. We can, pretty sure, can we divide 49 by 4? 49 divided by 4 is not divisible. Oh, holy crap. Alright, see ya, Bob John. Okay, we can't, so you have to find something that multiplies to 196 and adds to 26. Okay, so I'm gonna grab my calculator over here. And then I'm going to do 196 divided by 26, maybe? No, 196 divided by 6, 196 divided by 6 divided by 7, 28. We got 28 and 7, but they don't add to 26, so gotta look for other numbers. Divided by 4, gotta add to 26. 196 divided by 5, divided by 6. 196 divided by 7, 28. It's the closest one I have. It's the equivalent to 49 divided by 4, right? No? That's 12.25. The 4x squared plus 28x plus 49. 49 times 4. 196. Adds the 28. What the hell? That's the 28. Crap. No. No. Is equivalent. It isn't. No, that won't work. 28. Oh, 14 and 14. Nice. Okay, so then it would be 4x squared plus 14x plus 14x plus 49. And then we would get 4x squared plus 14x parentheses 14x plus 49. And then we can factor 2x plus 7. Whoops, no squared there. And then we can factor out 7 over here. 2x plus 7. No, wait. We can factor out 14, I'm pretty sure. 2.5, no. There's a 2x over here as well. Okay, so it's going to be 2x plus 7 times 2x plus 7. So 2x plus 7 plus 2x plus 7. That's going to be squared. Nice. Let's see what they did. Let's see if there's any faster way. 2x plus 2x plus 2x. Oh, they just factored it. Or not factored it. They just simplified it using FOIL. Which may have been faster, but anyways, I don't know any other method to find it. Which of the following is the equivalent to 2x to the power 5 minus 8x? Okay, so let's factor out. I immediately see we can factor out 2x here. So we get x to the power 4 minus 4. And these are perfect squares, so we can do 2x times x squared plus 2 times x squared minus 2. So then we're going to look for not one of these two, but it's going to look for x squared plus 2, x squared minus 2. I think it's this one. There we go. Things to remember: squares of sum, squares of difference, and differences of squares. I pretty much remember this already. Kinda. Except for this one. I need to remember this one. This one's maybe important. Okay, let's clear this out. Clutter. Okay, let's take a look at this video.
We're asked in the equation above.
Hold on, I will go get water real quick.
above, B
What is the value of a b plus c? So b plus c, 15, so whatever this times this is going to equal. Let me just get out my calculator. Yeah. Okay, let's see what he does.
B and C are constants. What is the value of B plus C? And they give us the equation over here. So pause this video and see if you can have a go at that before we work through this together.
Okay, so let's do this. See if we can do this before he does it. So you have to find b plus c. I'm gonna go ahead and try and factor this out. Plus 8x plus 15. I'm looking at 5. Oh, that was so easy. X plus 5, x plus 3. So it's going to equal 8. There we go. Okay, that was fairly easy. Rodev, you look familiar. Maybe I've seen you before.
I made an entire Roblox game on app.
Nope, never seen you before. Thank you, bro. Thank you.
We're asked if x squared.
Okay, so let's do this. Again, he's gonna tell us to do it. He's gonna tell us to do it before he goes through it. And x times y is equal to b. Times y is equal to b. Good thing I did that. Okay, which of the following is equivalent to 9a minus 18b? Okay, so x squared plus 9 y squared is equal to a, and x times y is equal to b. Let's see. To be honest, we can just, we don't even need to listen to that other first part. We can just factor it out. So let's do 3a minus 6b. Okay. And which of the following is equivalent? Wait a minute. Wait a flippin' minute. Harder structure. Which of the following is equivalent to 9a minus 18b? It can't be C and D. I can already tell. I think. X squared plus y squared is equal to a and x plus y is equal to b. Which of the following is equivalent to 9a minus 18b? Which of the following is equivalent to 9a minus 18b? Oh, wait, hold on. I can just substitute a with x squared plus y squared minus 18 times xy. X times y. And then we're gonna get nope, I'm clueless.
Plus y squared is equal to a, and xy is equal to b. Which of the following is equivalent to 9a minus 18b? Pause this video and see if you can figure that out. All right, now let's work through this together. So we have 9a minus 18b. But we know that a is equal to x squared plus y squared, and we know that b is equal to xy. So we can rewrite this as 9.
That's what I did. Okay. Or I mean, not the xy 18xy part. I just did it a little bit differently. Just formatted it a little bit differently. So 18xy. Okay, so now that we're given that, let's see if we can solve it on our own from here. Okay. X squared plus y squared is going to equal 9 times x plus y times x plus y minus 18xy.
Something. So this is going to be at the xy. Let me write the term. We have, see any plus patterns here.
Oh, why did I not think of that? I'm actually stupid. What the heck? How come I didn't think of that? Yo, guys, I'm actually stupid. 9 squared minus 18xy, and then we can format this to 9xy plus, or no, minus 18xy plus 9y squared. B. Desmos worked well on this one. Yeah, that makes sense. From here, we can just plug it into Desmos, but let's see if we can factor it. Just so we know if we can actually do it ourselves. Okay, so we can factor out 9 here, 9x in fact, and then we would be left with, no, not 9x, just 9, and then we'd be left with x squared minus 2y, 2xy plus y squared. And then now we can even factor this even further to 9 times crap.
Especially wide that way. I want this to be negative. So minus 3y, choice, all of that squared. Or it could be the other way around. It could be 3y minus 3x squared. So let's look at the choices, and it looks like it's 3x squared. That has so and let's see, over here, 3x times 3y would be 9xy. This is negative 2 times that. And let me write that way. So this is equal to negative 2 times 3x times 3y. So it looks like
What?
we have a perfect square that's dealing with 3x and 3y, and it looks like we would have to subtract one of them. So
What the heck? Where did he get that?
negative 2
If you don't mind me
times
how you did this with Desmos, just tell me real quick. 'Cause this for the sake of time here.
and let's see, over here, 3x times 3y would be 9xy. This is negative 2 times minus perfect square quadratics. So we can see that this over here, this is the same thing as 3x squared. It's actually, it could be plus or minus 3x squared. The one that we see on the right, let me do this in another color. This is plus or minus 3y squared. And let's see, over here, 3x times 3y would be 9xy. This is negative 2 times that. And let me write that way. So this is equal to negative 2 times 3x times 3y. So it looks like we have a perfect square that's dealing with 3x and 3y, and it looks like we would have to subtract one of them. So we could write this as, if I were to factor it, I could write this as 3x minus 3y. One of them has to be negative. So minus 3y, and then all of that squared. Or it could be the other way around. It could be 3y minus 3x squared. So let's look at the choices, and it looks like choice B is for sure exactly what we wrote down. Now, they could have had 3y minus 3x squared, and that actually would have been a legitimate choice as well. And if you don't believe me, you can actually multiply this out, and it will be equal to 9x squared minus 18xy plus 9y squared.
Okay. I plugged in 9x squared minus 18xy and 3x minus 3y to the power of 2 or all the option choices. It does allow that worked. 3x minus 3y. 3x minus 3y. Oh crap. Desmos. 3x minus 3y power of 2 gives us nothing. Hooray. What if we did that? What if y was 1 now? Yeah, what if y was 1? 9x squared plus 9x minus 18 18 squared plus 9x 18x. Nope, that's not right. You plugged in 9x power of 2 plus y power of 2. Whoa. Minus 18xy is equal to 1. Or, no, what are those equal to 0? Wow, that's weird. Okay, we got 1, 0. Is equal to 1. Oh, it's a plus right here. Oh, it's a circle. Oh, whoops. Hello. 3 1 instead of 3. Oh, I'm actually tripping. Whoa. They're all parallel. Oh, wow. I guess that's one way to do it. That's one way to do it. But I want to learn his way. It's probably much faster too. They get the plus minus 3x because it could be negative or positive. And then that makes sense.
I could write this as 3x plus or minus 3 times that. And let me write that way. So this is equal to 3x times 3y.
No, it's an exam before you finish high school. Take it before. Ignore the negative. Sal, what the freak? Wait, how is 9x squared equal to 3? Okay, that makes sense. I get that part. But it's just this part, the minus 2 times 3 of x. I don't get that part. it's this one here. I don't understand where he got 3x and 3y.
So it looks like we have a perfect square that's dealing with
Not necessarily where he got the numbers, but like more rather how he got to this point.
3y minus 3x squared. So let's look at the
Yeah, I get that part, but like, hang on. You have 3x minus 3y squared. I don't understand how. Negative xy. Take 9. Yeah, that's what I did at first initially. 2b. A minus 2b. A minus 2b. A minus 2b. Yeah, I get that, but how does he determine Oh, it's because x times y, considering that x times y is equal to b. Oh my gosh, I would not have figured this out by myself. Yeah, the reason why is it's because 3x times 3y right would equal b. No, wait. Am I being dumb? Am I actually tripping here? No, I gotta get new paper.
choices, and it
Okay. That's 324 right there. Let's take a look here. Which of the following is equivalent? Okay, cool. X squared plus y squared equal to a. X squared I'm so
It looks-
confused. Why did it disconnect?
looks like choice B is for sure exactly that way. So this here, 3x times 3y would be 9xy. This is negative 2 times that. And let me write that way. Times 3y. So it looks like we have a perfect square that's dealing with 3x and 3y. And it looks like we would have to subtract one of them. So we could write this as, if I 3y, and all of that squared. Or it could be the other way around. It could be 3y minus 3.
A minus b squared is equal to a squared minus 2ab plus b squared. Oh, I see. I see what you mean there. Oh, okay, I get it now. Oh, I see. I understand now. Alright. Let's go. A is constant. What is the value of A? No, I understand. The formula you gave me makes so much more sense. I'm gonna write this down on my piece of paper. Okay, I'm gonna go solve this. A is 7. I think I want to go over this though, see how they did it. Because I did it a little bit differently. Didn't really do any factoring. Didn't do any factoring at all to get this answer. Okay. How do I see the solution of this? Okay, which of the following is equivalent to 2x power 3 plus 4x? Oh, that's easy. What the sick? Oh, it's cubed. Are you actually kidding me? Are you flipping kidding me right now? Oh my gosh. I'm starting over, guys. Expressions is equivalent to just multiply it. Guys, am I dumb? Oh my gosh, I didn't see the negative sign. Guys, I'm actually so stupid. Okay, C is a constant. What is the value of C? Okay, let's take a look here. $12 is going to equal to C. 12. Okay, which of the following is equivalent? Let's not get this wrong this time. This one. This one is equivalent, right? Yeah, it's that one. So the following expression is equivalent to -2. So we're looking for a plus 2x squared plus 6. So the following is equivalent to the given expression. Okay, we can take out y, it seems, so we'll be left with y plus 4x plus 3. Y times y plus 4x plus 3. Okay, we gotta speed this up a little bit. What are radicals and rational exponents? Okay, 3 is the coefficient. Okay, exponential expressions are algebraic expressions with a coefficient. One or more variables. one or more exponents. For example, in the expression 3x to the power 4, 3 is the coefficient, x is the base, and 4 is the exponent. 3x to the power 4 is 3 multiplied by x 4 times. An expression can also be raised to an exponent. For example, for 3x to the power 4, you wish you had what? I'm pretty sure you can access this if you want. I think you just weren't aware. This is free. No ads, no nothing. Can you not access this website? This is free. So you can't access this specifically? Because this is free. Where are you located? That shouldn't be happening. I mean, you can access this anywhere, right? This can't be geo-locked. Huh? Did you already? Oh, right. You don't need it. You don't need to take the SAT. That's right. You probably don't have it in your country, but it's not that cool, to be honest. It's a very good source, yes, of course, but it's nothing amazing. Oh, you're French. I see. Okay. You probably don't have to take this test. Okay, so what are radicals and rational exponents? Cool. Rational exponents refer to exponents that are / can be represented as fractions. 1/2, 3, and -2/3 are all considered rational exponents. It's very, very interesting. It's a very different system of education. Probably very different methods of teaching over there as well. It's interesting. Very interesting to see, very interesting to have viewers from different countries who have different methods of learning. Anyways, I'm going to keep continuing. Radicals are another way to write rational exponents. For example, x to the power of 1/2 and x squared, x are equivalent. Okay, cool. Exponent operations, power of...
Do some example raising exponents. And I want...
Okay, this is going to be 21. It's going to be 21 to the power of 21 to the power of -5. And then 21 to the power of 10, right? 21 to the power of 10. Am I right? 21 to the power of 10. I lied, guys. I'm absolutely horribly wrong. Oh, wait. We need to make it so that it has no negative exponent. That's correct. Okay, that makes sense. So we would have to put it under 2. Only when it's being multiplied, of course, to put it under.
So let's say to the second power. Hopefully make intuitive sense. Here you have 8 to the 7th times 8 to the 7th. Well, you would then add the two exponents and you would get to 8 to the 14th. So however many times you have 8 to the 7th, you would just keep adding the exponents, or you would multiply by 7. Let's do 2 to the -10 power over 4. So this would be equal to 2 to the... We actually could think about simplifying this. -70th power to the 14th power. Power 4 is the same thing as 2 squared. And so now I can rewrite this whole thing as 2 to the -70th power over, well, 2 to the 2nd, and then that to the 14th. Well, that's 2 to the 28th power to be equal to 20. it's going to be negative 70 minus 28th power, minus 28. And so this is going to simplify to 4. And that's another way of viewing the same expression.
Cool. When adding or subtracting exponential expressions, we're essentially combining like terms. That means we can only combine the exponential expressions with both the same base and the same exponent. Both the same base.
Do some examples. Would be about
exponent. X to the base, x. Same base and same exponent. Okay, examples. 2x. 3x to the power of 2. Just adding these two together. Just subtracting those two together. Oh, that's okay. Yeah, that's easy. Okay. Multiplying, dividing exponentials. Multiplying, we'll add the exponents. Divide, we subtract. When multiplying or dividing exponential expressions with the same exponent but different bases. No, this is a review for the test. I have learned all of this before, but alright, I really don't use this math in real life. Because, like, even though I probably should, I just don't use math in real life as much. But I'm familiar with all this stuff. Maybe not the complex equations. The more complex equations are a little bit more harder to tackle, which I'm training, which is why I'm practicing right now to review and understand for this test. But otherwise, don't use it much. I'm already familiar with all this. Okay, we multiply or divide the bases and keep the exponents the same. Okay. Exponential expressions with the same exponent but different bases. Okay, that makes sense. Examples, 3, 12. Yeah, we just multiply those two together. And then power 4, just do that to the power 4. Right, so 4 minus 4. No. Negative 4. It's 81. Raising an exponential expression to exponent or a change of base. When raising an exponential expression to an exponent, raise the coefficient of the expression to the exponent. Keep the base the same and multiply the two exponents. Okay, that makes sense. The bases are numbers. We can similar rule, just multiply those two together. Change the base. Useful, let's see. A single exponent at the base of 3. So this would be 27 6x, right? We write 9 to the power of 6 divided with the base of 3. 3 squared. 3 squared. X power 6. Rewrite 9 to the power of 6 to the special with the base of 3 multiplied. 3 to the power of 2. 3x squared times 9x to the power of 6. exponents. Give me 1 second, guys. Sorry, I had to take a little break. Popsicle. Remember circle equations. I will get to the circles later. I'm pretty sure that's the next unit. Yeah, geometry and trig. So it's the next unit. I'm gonna go over this and then go over the geometry stuff. That's more recent, so I guess I get a little bit more familiar with that. Excuse me. Graphs for circles. Graphs for circles. Okay, so we have about 4 hours of study time left, and we should put that to good use. Let me check it out. Let me check out the other ones. Is it the same? Solving. Is it the same? Wait, hold on. Algebra. Wait, guys, I think it might be the same thing. What the heck? I think maybe the questions are a little bit different. That's probably what's different. Right? Yes, test is in Saturday. Test is on Saturday. So I gotta lock in. I also have to prep for the writing portion too. I actually never even touched the writing. I don't even know what I'm gonna write about. Like, I gotta get this math thing locked in. And then we're gonna do all these other stuff. I'm pretty sure they're all the same. Problem solving, data analysis, processing, data analysis. Yeah, pretty sure they're all the same. Let's go to advanced math. Yeah, they're all the same. I think it's just the questions that are a little bit different. So let's go back to our advanced math foundations. Go back to radical and rational expressions. All right, scroll down. Yeah, well, yeah, this a tricky thing for me, indeed. What score did you get? Just wondering. Okay, raising, change of base. Okay. Basis of numbers you can use. Cool. Okay, let's do the try it now. In order to divide 5 over 2 by 3 over x. 1520! 1520! Brother, that's insane. That's actually insane. Bruv, that's insane. That's actually insane, bro. Okay, wait, there's a writing portion, right? Popsicle, there's a writing portion, right? Or is there no writing portion? Is there a writing portion or no? Oh, if you signed up for it. Oh. Bruh, that's what I'm saying, dude. Kivio, that's the max score you can get for the math section. Oh, what sign up for? Wait. So the DSAT is all multiple choice, right? It's all multiple choice. I don't have to worry about the writing section at all? Because there's a part that says, it said, there's a writing section. There's an essay. There's an essay to do. Explain it to me while I do this. Okay, so we blank. Okay, in order to divide, we multiply the coefficients and I only took the practice SATs. The SATs they provide is just all multiple choice, but I'm not sure if there's going to be a writing portion or not. I think there is a writing portion, at least. Okay, so the coefficients and we in order to divide, we divide. Sorry. Then we subtract. Wait, bro, hold on. Sign on the colored board. Hold on. Are you sure? It's the exact same. I signed up for the SAT, and you did a writing portion. So, but like the practice one in here does not have a writing portion. Full length practice. If I press SAT, this is an SAT essay practice 1, 2, and 3. Wait, Popsicle. So did you make an essay or no? Did you make an essay or no? Wait, there's not writing. Oh, okay, so I don't have to worry about the essay portion. So what if I do sign up for the essay essay portion? SAT essay portion. How to sign up. Wait, Popsicle. So, you didn't do any sort of writing at all, like actual physical writing or typing, right? Oh, that's kind of crazy. Just answer my question real quick, because I have to maximize my studying right now. Okay, thank goodness. Thank absolute goodness. Popsicle, I swear, if you're actually lying, bro. If you're lying, I swear I'm gonna go find you. I'm gonna call you out on YouTube. Okay. I'm trusting you. Okay. Yeah, I did do the blue book test. This is the SATs. So just all multiple choice, right? All multiple choice. That's so odd. Very, very odd. Yes, sir. Yes, sir. Thank you for the help. Thank you for the help. Yeah, I thought there was a writing portion too. But I should be okay. I should be okay. Okay, so let's continue this actually. The coefficients, we divide the coefficients. Yes, we divide the coefficients and subtract the exponents. So we would be left with, let's see, 4x, we would be left with 4x, the power of 2. There we go. Okay, to calculate 2 to the power of y, no, 2 times y to the power of 4 over 3 to the power of 3, we multiply 2 and 4/3, I would say. 2 and 3, no. We coefficient operation, we square 3. And the exponents. So we multiply the exponents. So what we would do is we would now have 8y to the power of, let's see, hold on. Let me do this on my calculator. 64, 3, 9, 27 is 2, 10, 27. Right, we multiply. Oh, no, we multiply. No. I'm stupid. So no, that's going to be to the power of 4. To the power of 4. I am stupid. I'm stupido. 4/3, 12, 4, cube, 2 times 2, 4, 8. We square 3. Square 3, right? We cube 2. Wait, why do we cube 2? Oh, I worded it wrong. I'm so stupid. I thought like we were supposed to score. I worded it wrong. Yeah, well guys, I understood that. It was just a miswording. It's the miswording. I consider that as a correct answer on my part. So let's... Okay, determine whether each expression is equivalent to 7 root v to the power of 3. Okay, this would be equivalent. This is the equivalent. I'm very sure this is equivalent. This is not equivalent. This is the dumbest thing I've seen. V3 over 7. It is not this. So this is the only equivalent one, I'm pretty sure. Oh, wait. I think I went too far. Oh, wait. Those two are equivalent. What the heck? Oh. Oh, I see. Okay, great. And I have guys speaking German in my chat. That's great. Okay, so equivalent, not equivalent. 7 root 3 root v3 is equal to v3 power of 1/7. Okay, so I guarantee this is not equivalent. I know this is not equivalent. I wasn't too sure about this one, so this one was wrong. The reason why, excuse me, so it's going to be v to the power of 3, 1/7. And we multiply those two. I'm burping a lot. So excuse me, sorry guys. Following equation is true for g is greater than or equal to 0 and d is a constant. Okay, yeah, it's doing in an account that this is square root. What is the value of d? So the value of d is going to be 5 over 6, right? 5 over 6? 5 over 6? Hold on, before I say anything. Pretty sure it's 5 over 6. 5 over 6, right? Yes. Okay, so the following equation is true for x is greater than 0 and d is a constant. What is the value of d? It's going to be negative 1/7, I'm pretty sure. Negative 1/7? You might have put negative. This one might be negative. Yeah, no, it's negative 1/7.
1/7.
There we go. Okay, nice. Alright, roots and rational exponents. This one's easy. Easy. So this would be the same thing. This would be equivalent. It's equivalent to that. Whether each of the radical expressions is equivalent. Okay, so let's take a look here. We have x, 3 over 2, root 2 times 3. This is the same as this, okay? Times 3. This is equivalent. Root x times y. I like how you spelled MCQ backwards. Like, how do you manage to do that? How do you manage to spell MCQ backwards? Square root of x times y. No, it's not right. Right? No. For multiplying, we add, so it would be 6, 3, 9, 2. Hold on. 3 over 2 plus 1 over 3 is 1 5/6. So 7 over 6. If we're multiplying then, this is not equivalent. I might have to go back to that one. What does QCM stand for? MCQ and R in the United States is multiple choice question. Is it the same for over there? Okay, so let's see. X to the power of 3 times, this is not equivalent. It's going to be a cube root here. That's supposed to be cube root. Particularly looking at this one here. This one. So this one might be equivalent as well. Yeah, no, I think this one's equivalent. This is equivalent. I did the fractions. There we go. Okay, so this is going to be 6x to the power of 8. Okay, if a is b over 2, then the power of b over 2 is equal to 25. For positive integers a and b, what is one possible value of b? Yeah, you should head to bed. Okay, one possible value here is 2. 1, 2, and 4. Okay, if n what is n in terms of x? What is n in terms of x? I know what to do. Okay, so n power of 1/3 equals x is equivalent to 1 over n to the power of 1/3 is equal to x. Okay, and then we multiply n over 1/3 both sides. And is going to equal good night. No, it's not going to work. Okay, wait. In terms of x. Okay, so square root cube root s to x. Let's see. Wait, what? This one might be this one? Where did the exponent of n? I'm so confused. 1 over x to the power of 3. Oh, I see what they did. Okay, do you guys get it? I get it. So what we do... No, I don't get it. Wait, no. Raising both sides of the equation, the exponent of -3 gets rid of the exponent of n. Raising both sides of the equation to the exponent -3 I see. Man. Okay, I understand. I understand where they got this. Which of the following is equivalent to the expression above? Okay, so this is equivalent to... No, wait. These would have to be the same. These would have to be the same. Right? Am I tripping? Two... Adding and subtracting. That cool. Okay, that makes sense. But these aren't the same, so... So what do we do from here? So what do we do here? What if you divide a square root? Oh, I'm so clueless right now. I'm looking at this one. Yeah. Let's take a look. Oh, that's equivalent. Okay. What do we do from there? Square 4, square root x squared times square root y 6. Oh, they just simplified it. They just simplified it. Oh my gosh. Oh, dude, I swear I can't solve these hard ones. It's always the last one I struggle with. They simplified it, and then this crossed out. This crosses out, and be left with. What does x squared cross out with? Wait, 2 crosses out. Oh, we'd be left with x, so it'd be x to the power of 1. What? So we'd be left with 1 x times that, and then they resimplified it too. Oh. Okay, let's do this.
which of the following values is equal to the value above? And we got this expression here.
Okay, let's go ahead and simplify this real quick. So our, actually, before we do that, let's see. Okay, so none of them are in like the square root symbol thingy, so I don't think we have to convert it any farther. Okay. I'm gonna say 1. No, it's not 1. How does he do it? Let's redo it, actually. Let me do it real quick. Which of the following values is equal to the value above? Okay. Multiply 3 times 1/3. 3 1/5. Oh, I see. Okay, so we cube this. Let's cube. We can cube, No. No. No, let's do it to the power of 9. Right? Am I trippy? No. We can just cube it. Let's cube it. Then we'd be left with 3 to the power of negative 1/5 times... Right? Yeah, hold on. Times 1. Try put everything in the shape of 1/3. 3. Okay, so the power of 9 then. Yeah, right. So, let's do the power of 9. Let me double check to see if that equals 3.
This as taking our original base, and here is still going to be. And so this is going to be equal to 3 to the negative.
Dude, I swear they're actually bringing these up out of nowhere.
3 to
Like, like what the hell? This is genuinely making me so mad. It's like they're making stuff up.
the negative.
Okay, let me go back and review these exponents real quick. Okay, let's go to our things to remember here. understand that. Understand this. A times b m plus n. Yeah, well, like, he just wrote that down. But, like, I... It's an exponential expression to explain it. Oh, there we go. Yeah. I guess it's just as important, then. Just multiplying these in both. And this one just multiplies with that. These are just simplified versions. Multiplying. Dividing is just dividing these two and then n minus n. Okay, I think we're ready. Okay, let's go ahead and do this again. If we see a fraction, we can convert that to a negative. And then we do this, we multiply these two together, and then we'll get 2 over 5. Just gonna write that down soon, right here. 2 over 5, and then we add these two together, and then we'll get 3 to the power of 1 over 5. Okay, I get that one now. Okay, so let's see if we can actually remember these formulas or properties or whatever. Apply it here. So, what if 2x minus 3y is equal to 4? 2x minus 3y is equal to 4. What is the value of 4 to the power of x over 8 to the power of y? What is the power of x? Divided by 8 to the power of y. Here, let me think for a second real quick. Let me see the chat. Is the value of 4 to the power of x over 8 to the power of y. Oh, this simplifies to 1 over 1 to the power of x and 2 to the power of y. Okay, notice that. Okay, let's solve for x here. Is there like a property that I'm missing? 2x minus 3y is 4. Yeah, I'm noticing that too. Can't really think of anything. Let's see if we can solve this on our own first. He did it in 3 minutes. It's kind of impressive. There's probably like a really like simple thing that we're probably just not thinking of. But I did find that 4 to the power of x over a to the power of y. Wait. One of the things was the same x, 4 to the power of x over 4 to the power of y. It's gonna be 1/2 to the power of xy, if I'm correct. 1/2 to the power of xy. Is the value of 4 to the power of x.
Vô nào. Sit. Ba cái giường ghế mà cứ cho lên cô rinh.
So y. Huh. One to the power of x. Wait a minute. Wait, it's gonna be 1, right? I think it's gonna be 1.
Ooh, this is good.
60, what? No, it's gonna be 16. I thought it was 1.
What I have here on the left to get what I have here on the right. But another way to approach that is to say, look, this thing on the right looks a little bit suspicious. 4 and 8, 8 isn't a power of 4, but we know that they are both exponent, and then raise that to another exponent. That's equivalent to multiplying the exponents. So this is going to be equal to, and right over here, it's going to, and we can use other exponent properties. You might recognize that if I have a to the x over a to the y, okay, this is the same thing as a to the x minus y. And we explained the intuition of that in 2x 3y is equal to 4.
Oh. Oh. Yes, thank you, thank you. Okay. Okay, b to the power of 3 times b to the power of 4 power of 2 is equal to b to the power of x. So we have b to the power of 3 times b to the power of 8 is equal to b to the power of x. And then b to the power of 11 is equal to b to the power of x. Value of x is 11. 5 to the power of a, what is the value of 5? Value of 5 is going to be 1 over 5. Right? No, sorry. 1 over 2. But let's do that again because that kind of messed me up. Here's a harder one. Which of the following following is equivalent to the expression given for a and b is not equal to 0? A and b is not equal to 0. Okay, so a8, b2, a2, b10. Okay, and this one we're going to let's see, divide x by y. No, this is a better example here. A over b times x m minus n. Oh, wait. So this is going to be a6 and b negative 12. a6, b negative 12. This one. Oh, holy crap. What the heck? That was so easy. Wait, I think I'm starting to remember it now. If 2 to the power of a is equal to 9, what is the value of a? Okay, the value of a here is going to be 4 over 9. Just let me double check that real quick. Yeah. Okay, which of the following expression is equivalent to the given expression for all a is not equal to 0? Okay, it's going to be 3 times 3 is 9 times negative 9. It's going to be 0. It's going to be 1. Okay, 7 to the power of a is equal to 8 to the power of 7 over 3. What is the value of a? The value of a is going to be 3 slash 8. Nice. We got a couple more, and then we're going to go to the harder ones. I will be right back.
4. We're told 2x
Oh. Okay. Alright, let's do our practice here. Okay, so what of the following is equivalent to 3 to the power of 8 to the power of 2? It's gonna be this one right here. No, 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 no. Yes, 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 yes. Are you flipping kidding me, guys? What the actual sigma? We'll take one step at a time. 3 the power of 2a. Wait, no. Yeah. Wait. What? What? 2 times a. Don't tell me you have to multiply it. No. No, 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 no. 2. So it's gonna be 9 2a. 9 2a. Look at this one. Wait, why is that? 3 2a does not equal 9 2a. Oh, sorry. There we go. We're squaring 3a and 3a. Yes, I'm a junior. So it's gonna be 3a times 3a, right? So it's gonna be 3a. Am I tripping? Do we not square the thing? I think. Wait, hold on. Oh. I see. This is why. Mix it up with this. Okay, so AB times X. Okay, anyways, this is only if this thingy here, the base? Is it the base? I think it's the base, right? That's what it's called. The boss? Yes, the base must be the same in order to multiply together. So we can just, okay. Let's start over. Gotta keep it on a streak. Okay, so if 2 to the power of a is equal to root 4 root 2, what is the value of a? What is the value of a? So this is going to be, no, 1 over 4. 4. Just to make sure, yes, this is 1 over 4. Okay, which of the following is going to the given expression? It's the same thing as, this is the same thing as, AMN times AMN, which is 2 AMN. Oh my gosh, this is so stupid. A2MN. It's so dumb. Wait. Yeah, I'm getting these mixed up. I'm getting these so mixed up. This is actually annoying. This is what happens when you don't get enough sleep. This is not going so hot. A times B. Oh, it's 1 times 1. Oh, I see. Okay, we starting over again. Okay, 3, what is the value of A? A is 1, 5. Equivalent to 2x3. 3x. 2 to the power of 3 times x. Right. No. It's just gonna be plain x. So it's gonna be. There is a crow on top of my house. Yeah, I know it's 8x. What is the value of a? A is going to be 2 over 5. Right? Yeah. If 11 to the power of a is equal to 11, this is going to be 5 over 6. Cool beans. What are polynomial expressions? My max bench press? Oh my gosh, bro. I had literally had to skip. I had to skip the gym for 4 weeks. Because I had to study for this crap. I'll be able to get to the gym next week. But I do expect a very significant decrease in strength, considering I was gone for 4 weeks. The reason why is because the first week I was taking a 1 week break, but then the second week I got sick, and then the third week is when I started studying. Now here's the fourth week. It's this week, and yeah, next week will be when at its peak. I was benching. Let's see. I was benching 160 for 7 reps. Yeah. Oh man, I don't know. I gotta eat a lot again. Gotta start eating. But that's not necessarily important. I think it's fairly easy to get that strength. You just gotta eat a lot. You gotta train consistently. It's definitely. I weigh 140. Well, at the time, I was benching 160. Probably weigh a lot less, considering don't work out as much. It's the past 4 weeks. But let's continue on with this.
Is the mouse PC?
The exponent of the term 2x is 1. X is equal to the x to the power of 1. 3x to the power of 4 plus 2x plus 7 is a trinomial. 7 is a constant term. We can also think of 7 as an exponential term. How do I add and subtract polynomials? Let's see.
X squared. If this was a minus, then we'd have to distribute the negative sign, but it's not. It's 2. And we've simplified.
Oh, it's so easy. And I wish this was as easy as the other ones. Hopefully we can complete all units, because everything else is the same content, but just probably harder questions. So, finish geometry and trig today, and then, yeah, that is definitely going to be finished today. Algebra, problem solving, all this other. Actually, these are the exact same as before. So, all the medium and harder questions is most likely tomorrow, maybe today, most likely tomorrow. Oh man, wow, oh my gosh. Oh, that's a lot. Holy crap, I actually gotta start working now. See if you can get it within the next 4. I have to eat too. Considering that, I think I'm actually gonna go eat. Or let's actually finish this first. Was I here? No, I was not here. Radicals, exponents. Nonlinear functions? No, that's not where I was at. Where was I? Right here. Okay. Here. Okay, that's easy. That's also easy. have the same base, same exponents can be combined, have same coefficients, the two different exponents. That is the better option here. Expression is equivalent to 5x. This is 5x. This is 2x squared plus 7x. This is okay. Anyways, I had to scold someone real quick.
Oh, yeah, scolding someone.
Okay, so we can simplify this to, this is gonna be 7x. This should be right. Yeah. Okay, so how do we multiply? Let's see what he does over
We
here.
aren't done yet.
Yeah. This is very easy.
The negative 7.
For some reason, this is like the most easiest concept for me to understand. I just don't understand. When multiplying 3x, we add the coefficients of the terms. No, we multiply the coefficients of the terms, and we add the exponents of x. So this one would be 6x to the power of 2. No, 3. Sorry. Using FOIL. So let's see. 8x. They already gave it to us, so we can just put it here. Whoa. Oh, okay. 8x times x outer and 8x times 1. Negative 3 times x squared. And then we're gonna get negative 3x squared. And the last is negative 3 times 1. There we go. Which of the following is the sum of x squared? It's going to be 3x squared plus 4x plus 5. see. Let's do FOIL. Wait, now hold on. The equation above is true for all x where a, b, c are constants. What is the value of b? Okay. Huh? We moved on to a little bit further. Oh wait, no, I'm not here yet. Sorry. So it's way down. Okay, yeah. Yeah, that makes much more sense. Yeah. You can plug these into Desmos. So. Or not this specifically, of course, but like this format. This format here. X squared plus bx plus c. Or minus c or whatever. Not for this specific question, of course. Equation above is true for x where a, b, c are constants. What is the value of b? Yeah, I'm gonna have to manually solve it here. Of course, this is very easy. It's just so it's gonna be negative 15x squared plus 9x. B is 9, pretty sure. Okay. Which of the following is equivalent to this? We're gonna have a 2x squared for sure. Gonna have a minus 15 for sure. 2x squared and a minus 15, so that leaves us with these two options. It's gonna be this one here. The equation above, a and b are constants. What is the value of ab? AB. What is the value of a and b? Or a times b at least. Okay, so let's factor 9x squared plus 21x plus 6. 3. Yeah, we can take 3 out of this one. Three x squared, so 6, 7, and 1. 7 minus 1, 3x squared plus 7x minus x plus 2. Wait, no. Right? No, yeah. 7 and 1, 7 and 1. Okay, I don't know why. I was tripping out.
Oh,
Wait. 54. You need new paper again. Wait. Is this 9? Wow. See what they did to actually, like, mathematically solve it. Oh, they literally just factored it. Okay, got it. Mnemonic foil. Cool.
Which of
Wow. Okay, which of the following is equivalent to? Okay, they're giving us these absurd numbers here. But it's probably a lot easier than we think. Just distribute -1. Okay. This option right here. This one. The second one here. It's going to be our answer. 100. That's how many he has. Oh, that's funny. Okay, let's do this harder example here. Which of the following expressions is equivalent to 7k minus the product of k plus 1 and 2k plus 2? Oh, wait, I think I get it, guys. Two K plus 2K. Wait, I think I did something wrong. But I'm pretty sure it's the first option. Minus. Oh, wait, I see where I did it. I see where I got it wrong. Okay, hold on. 7k minus. 2 squared. 2 squared plus 4k plus 2. And then it'll be 7k minus 2k squared minus 4k minus 2, and then 7 or negative 2k squared plus 3x minus 2. Yeah, okay, so it's gonna be our first option here. There we go. Wasn't too hard. For real, man. Okay, after this, I'm gonna go ahead and eat. Let's see how many more things we have to go over. That is a lot of things we have to go over. And a lot less things we have to go over. Nice. Okay, we're almost done. We're almost done. Okay. Let's go ahead and do this real quick. Which of the following is equivalent to the given expression? Can you guys see my screen? Yes, you guys can. Okay. We're looking for 4x here. 4x minus... No. Yeah. 4x minus 5x minus 5. Okay. Which of the following is equivalent to the given expression? We're looking for a negative 6xy squared. Right? Negative 6xy squared plus y to the power of 3. No? Oh, no. Oh my gosh, no, I meant this one. Sorry. I said negative 6xy squared. Okay. 4x. We're looking for x squared plus 4x is one of these two. We're looking for plus 5. Expression is equivalent to the given expression. Times f. Okay, let's do this here. This looks a little confusing. F plus 19 times f. We're looking for an 18f squared plus 19f. Looking at this one right here. Which of the following is equivalent to is an equivalent form of this? Okay, so we're looking for negative 5x. Here's one of these two. Plus 9. Which of the following is equal to this? X to the power of x squared plus 9. So x to the power of 3 plus 9x. Power of 3. Okay guys, I'm gonna go eat. I am kind of starving right now. I will be right back. You guys can listen to some music while I go eat. Okay, guys, we're back. We're back. We're back. We're back. We are indeed back. We're gonna hop on back to main and we're gonna start locking in. Whoa, guys, I just got a water bottle that's like absolutely filled to the brim. This is actually kind of funny. Okay, guys. Okay, rational expressions look like fractions that have variables in their denominators and often numerators too. For example, x squared over x plus 3 is a rational expression. Just as we can add, subtract, multiply, and divide fractions, we can perform 4 operations on rational expressions. Okay. Learn to simplify rational expressions, add, subtract, multiply, and divide, and rewrite rational expressions in the form of quotients and remainders. Let's take a look at this video.
When we first started learning about fractions, or rational 3 in this case, we could divide the numerator by 3 and the denominator by 3. Once again, we know that this is the same thing as 8 over 3 times 8, or this is the same thing as 1 over 3 times 8 over 8. The 8's cancel out, and we get this in lowest terms as 1/3. The same exact idea applies to rational expressions. These are rational numbers. Rational expressions are essentially the same thing, but instead of the numerator being an actual number and the denominator being an actual number, they're expressions involving variables. So let me show you. Out of 4. The numerator and the rational 12 divided by 4 is 3. 12x over 4 is 3x. Plus 4 divided by 4 is 1. So here, just like there, the numerator and the denominator have a common factor. In this case, it's 3x plus 1. In this case, it's a rational, it's a variable expression. It's not an actual number, but we can do the exact same thing. They cancel out. So if we were to write this rational expression in lowest terms, we could say that this is equal to 3 over 4. That's equal to 3 over 4. Let's do another one. Let's do another one. Let's say that we had x squared, let me see, over 5x plus 15. So what is this going to be equal to? What is this going to be equal to? So the numerator, we can factor. It's a difference of squares. We have x plus 3 times x minus 3. Cancel them out. But we can 5, but we have to exclude the values of x that would have made this denominator equal to 0. That would have made the entire expression over 3. Negative 3 would make this 0, or it would make this whole thing 0. So this and this whole thing are equivalent. This is not equivalent to this right here, because this is defined at x is equal to negative 3, while this isn't defined at x is equal to negative 3. So to make them the same, I also have to add the extra condition that x cannot equal negative 3. And so likewise over here, if this was a function, if this was, let's say this was, we wrote y is equal to 9x plus 3 over 12x plus 4, and we wanted to graph it. When we simplify it, the temptation is, oh, well, we factored out a 3x plus 1 in the numerator and the denominator. They cancel out. The temptation is to say, well, this is the same graph as y is equal to the constant 3/4, which is just a horizontal line at y is equal to 3/4. But we have to add one condition. We have to exclude the x values that would have made this thing right here equal to 0. And that would have been 0 if x is equal to negative 1/3. If x is equal to negative 1/3, this or this denominator would be equal to 0. So even over here, we'd have to say x cannot be equal to negative 1/3. that condition is what really makes that equal to that. That x cannot be equal to negative 1/3. Let's do a couple more of these. And I'll do these in pink. Let's say that I had x squared 5 minus x minus 2. So once again, we want to factor the numerator and the denominator, just like we did with traditional numbers when we first learned about fractions and lowest terms. So if we factor the numerator, what two numbers, when I multiply them equal 5, and I add them equal 6? Well, the numbers that pop into my head are 5 and 1. So the numerator is x and 1. 5x plus 1x is 6x. So here we have a positive 1 and a negative 2. So x minus denominator minus 2 times x plus. We have a common factor in the numerator and the denominator. These 5 over. We have to add the condition that x cannot be equal to negative 1. We cannot, because if x is equal to negative 1, this is undefined. We have to add that condition because this by itself is defined at x is equal to negative 1. So we have to add this condition for this to truly be equal to that.
Okay, we're gonna try this out. Okay, so we have a polynomial on the top and a polynomial on the bottom. And they seem to have factored it out over here and factored it out in the bottom. The rational expression x squared minus 5x plus 6 divided by x squared plus x minus 6 is factored as shown above. Since both the numerator and denominator contain blank as a factor, contain x minus 2 as a factor, we can cancel the identical factors to simplify the expression. So this would be equivalent to x minus 3 over x minus 3 over x plus 3. Pretty sure that's right. Okay. How do I multiply and divide rational expressions? Let's take a look.
So up here we are multiplying two rational expressions, and here we're dividing one rational expression by another one. And what I encourage you to do is also see that both the numerator and denominator are divisible by be equal to 0. Another way to think about it, if you had a function, f of 0 is undefined. Undefined. Why is that? Because you put x equals 0 there, you're going to get 2 divided by 0. It's undefined. Of course, x to 0. So now it would be defined at 0, but then this would make it a different function. These are two different functions the way they're written right over here. Instead, to make it clear that this is equivalent to that one, you would have to say x cannot be equal to 0. Now these functions are equivalent, because now if you said f of 0, you'd say, all right, x cannot be equal to 0. You know, this would be the case if x is anything other than 0, and it's not defined for 0, and so you'd say f of 0 is undefined. So now these two functions are equivalent, or these two expressions are algebraically equivalent. So thinking about that, let's tackle this 0 to 0, which is reciprocal of the same. To be algebraically equivalent, we have to give this same constraint. The form of 8x to the fourth, 4 times 2x to the fourth, over 7 times 5 times x to the fourth is 35. Here both the numerator and the denominator are divisible by x to the fourth. So let's divide by x to the fourth, and we get 8 over any x algebraically equivalent cannot be equal to 0. And to see, this even seems a little bit more nonsensical to say x cannot be equal to 0 for an expression that does not even involve x. But one way to think about it is imagine a function that was defined as g of x, 8/5. Well, now g of 0 would be defined as 8/35, which would make it a different function. So to make them algebraically equivalent, you could say g of x is equal to, or you don't even have to include that second row, and that will literally just make it undefined. But now this expression, this algebraic expression, is equivalent to our original one, even though we have simplified it.
Okay. The same rules for multiplying dividing fractions apply to multiplying and dividing rational expressions. Multiplying two rational expressions, we multiply the top row and we multiply the bottom row. When dividing two expressions, recall that dividing by a fraction is equivalent to multiplying by that fraction's reciprocal. So if we divide by this, you just switch over the values, and we just do the same as we did up here. We multiply the top row and the bottom row, and eliminating anything that is cross-multiplying, or if any of them are the same, then we just cross them out. However, to avoid lengthy polynomial operations, it's recommended that you factor and cancel any cancelable factors before you write out the final expression. To multiply two rational expressions, factor any factorable polynomial expressions in the numerators and the denominators. Then cancel out any identical factors that appear in both the numerators and the denominators of the expressions, and finally multiply the remaining numerators and multiply the remaining denominators. Okay? Identical operators that appear in both numerator and denominator expressions. Okay. Dividing two rational expressions is similar to multiplying. Just remember that dividing an expression is equivalent to multiplying by the reciprocal of the same expression. Okay, so what is the product of, let's write it down here, x squared over x plus 3 and x plus 3 over x. Okay, right, so we can take out x plus 3, they're both the same, and we're going to be left with x squared over x. Right. So there are options here. It's either x squared over x. No. It's going to be just x. There we go. X times x, and then we have our x right over here. Okay, so if f of x is equal to x squared plus 2x plus 1, and g of x is equal to x over x squared plus 4x plus 3, what is f of x divided by g of x? Okay, first let's write down our equations, and g of x, okay, so we're going to divide this by, but if we're going to divide it, it's going to be the reciprocal, right? So let's just switch our, let's flip it right there, right now, and multiply it rather than having a big division symbol under our thing. So let's do x squared plus 4x plus 3. Okay, and then we're going to cross out any common factors. F of x divided by g of x. Divided by g of x. Okay, yes. So let's cross out any common factors here. Okay, so we've got that one. And we've got that one. And then we're going to be left with 2x plus 1 times x plus 4x plus 3. And we're going to be divided by 3, right? And then we're going to simplify this even further. Let's do that times 4. There's one thing here that we can do. Oh wait, I forgot to do x plus 2x. Sorry, excuse me. There's two things we can do here. We can simplify this to 3x plus 1 times 5x plus 3. And we divide that by 3. Then what we can do next is use FOIL plus 9x plus 5x plus 3 over 3. And then 15x squared plus 14x plus 3 divided by 3. That's what I got. Let's see what they got. Is x plus 1 cubed. It's interesting. X squared plus 4x. Huh. Okay, so we factor it first. We factor anything first. Okay, always remember, factor first. Okay, it's a good thing to know. So let's do it for this one here. Identify the factorable numerators. Before multiplying, Raj wants to factor the numerators and denominators. Which of the following can be factored? We can factor this. And we can not factor that. Or that, I'm pretty sure. This one's definitely factorable. 3x plus 3. This is not factorable. The correct number of answers. This one might be it then. There we go. Oh, well, that's considered factoring. Okay, that's kind of, okay. Hold on. Adding rational expressions.
Pause the video and try to add these two rational expressions. Okay, I'm assuming you've had a go at it. Now we can work through.
Okay, so let's go ahead and give this a shot. 5x over 2x minus 3 plus negative 4x squared over 3x plus 1. Yeah, let's take a look if we can factor any of these. We can't factor any of these, it seems. I don't know.
This together. So the
Oh, you hate Khan Academy? I think it's a pretty useful source. It's a pretty good source. I mean, it's not too bad. Not the worst source in the world. I think it's pretty helpful. I think it's just time consuming is all I can say. But otherwise, all the stuff is just really helpful. I still have to do the SAT reading and writing part. Anyways, we're gonna continue on with this. Let's see here. We're gonna
pause the video and try to add the.
Don't know how to add, so we're gonna watch this video.
Is you realize that they have different denominators, and it's hard to add fractions when they have different denominators. Plus something else over 2x minus 3 times 3x plus 3. Let's be even. And so let's set up a common denominator. So this is going to be equal to, it's going to be equal to get 1 plus 2 times 3x over here 2x minus 3 does not equal 0, which is negative minus 3. And I can rewrite all of this business in plus 5. Should we time to do that spider the 8x denominator? We have a common denominator now, so we were able to just add everything. Is 2x minus 3. What can we draw? Look at, we can x squared. The r add an x out of the numerator, but that's not going to cancel out with anything in the denominator, and it looks like we are all done.
Okay, I got it. I sort of got it. Okay, let's read this though. The same rules for adding and subtracting fractions apply to adding and subtracting rational expressions. When adding or subtracting two rational expressions with unlike denominators, we multiply with d and we multiply with b on this side. Okay, and then we just divide that. We add or subtract the top parts. And then remember, you can only add and subtract the numerators if the expressions have a common denominator. In most cases, the easiest way to find a common denominator is to multiply the two unlike denominators b and d. To add and subtract two rational expressions, find a common denominator for the two expressions. In most cases, the product of the two denominators would work. Rewrite the equivalent form of each rational expression using the common denominator. Add or subtract the numerators of the expression while retaining the common denominator. Combine like terms and write the result, and then factor and or cancel as needed. Okay, let's do this one here. Don't need that one anymore. Let's do this one now that we know how to add. Okay, x plus 3, I'm going to make that a little bit. X plus 1. Okay, let's try multiplying these two together. Okay, I'm going to be left with okay, so now that we have a common denominator, we can multiply x plus 3 on both sides. Let's do that real quick. X plus 3. Right. Is multiplying. Oh yeah, we also have to multiply x plus 3 in the top and x plus 1 on the top over here. Okay, and then we're going to be left with 2x plus 6 on the top minus it's 3, right? Yes. 3x plus 3. Now that we have a common denominator, we can just mush them together. It's x plus 1 times x plus 3.
Hello? Hello? What's up, bro? Rồi. Sao mà mày gọi?
Okay, I just got my answer. So what I got was 2x squared plus 3x plus 3 divided by x plus 1 times x plus 3. Assuming that I don't have to factor it any further. Let's see what they got. Are you kidding me? No, that's not what I did. I had x plus 1. No, I did this one right here. I did this one. Bruh. Are you kidding me? Bruh, are you kidding me? X plus 3, x plus 1, 3x plus 3. Oh, I see where I got it wrong. Okay, so I forgot to put this in parentheses. And it, whoops. Okay, so this is going to be 2x squared. 6x. What the hell? X plus 3. X plus 1. X plus 3. 3x plus 9. 3x plus 9. Oh, I kind of formatted this incorrectly. Yeah, hold on. Okay, let's redo this real quick. Sorry, guys. I formatted this horribly. Minus 3 over x plus 1. Multiply the common denominator, so we multiply x plus 1 here. Multiply x plus 1 here. Multiply x plus 3 here. and then multiply x plus 3 here. Okay, and then we're going to be left with 2x squared plus 2x minus 3x minus 3 over x plus 3 times x plus 1. And then I'm going to be left with 2x squared minus x minus 3 over x plus 3 times x plus 1. There we go. Hello, Zahid. See if we got it right. 2x minus x minus 9. They got minus 9. How in the hell did we get that? I'm so. Oh, there we go. I found it. Okay, well, 2 minus x minus 9. Okay, found my mistake. Okay, let's do this one. Celesta wants to find the sum of 3 over x and x time, or x over 2x minus 3. In order to add the two rational expressions, she must find a common denominator. Well, the sum, right? I thought she was multiplying for a second. She must first find a common denominator by multiplying the two denominators here, right? To get a common denominator. Next, she needs to rewrite each rational expression using the common denominator. The first term can be rewritten as, I forgot a parenthesis here for some reason. And the second term can be rewritten as 2x. Okay, yeah. So the second term can be rewritten as x squared, or actually, I think I'm going a little bit too far. I'm going to do 2x minus. Yeah, 2x minus 3 times x. Includes a wrong variable letter. Excuse me. Excuse me. You're telling me that this is wrong? Couldn't grade my answer? I'm saying that it's not good enough? I might have to... No, I'm pretty sure this is... What? Bro. Okay, maybe I have to simplify these together. Oh, no. This is my fault. This is supposed to be not here, in fact. Right? Yeah, that should be right. There. Yeah, that's a lot better. Okay, so actually the other way around is equivalent too. I think I just have to add the parentheses. That's what, no. I'm pretty sure it's equivalent. Okay. Anyways, dividing polynomials by linear expressions. Okay, so how do I rewrite a rational expression as a quotient and a remainder? Okay, let's take a look.
We're told divide the polynomials. The form of your answer should either be just a clean polynomial or some polynomial plus some constant over x plus 2 where p of x is a polynomial and k is an integer. Fair enough. And if we were doing this on Khan Academy, this is a screenshot from Khan Academy, we would have to type this in, but we're just going to do it by hand. And like always, pause this video and try to do it on your own before we work through it together.
Okay, so my first initial thought is to separate the x plus 2. Yeah, separate the x plus 2 here. So, plus 7 over... no, times... divided by... Yeah, 1 over x plus 2. Right. No, honestly. Clueless. I'm clueless. Don't know what to do here. Oh, wait, hold on. Maybe I could factor... No. No, I can't do that. X plus 2. Yeah. Clueless. Gotta watch.
All right, now let's work through it together. And what we're trying to do is divide x plus 2 into 3x to the third power plus 4x squared squared 3x squared times. We'd want to put that x way, we'd want to subtract what we just squared. X negative around the whole 7. Well, 2 is 2. It's a little lot. Writing it expression that x cannot be equal to negative 2, because if x was equal to negative 2, we'd be dividing by 0 here. But 2 in the world, but it's we're told.
I do have a faint memory of doing this. Let's take a look here. So 3x, the 3x cubed subtracts 3x squared. Wait, I've gone a bit too far.
3x squared times, we'd want to put that in the second degree column. 3x squared. 3x squared times 2 is 6x squared. 3x squared times x column. 3x squared. 3x squared minus 3x plus 7. And so, like always, we focus on the highest degree terms first. X goes into 3x to the third power how many times? Well, 3x squared times. We'd want to put that in the second degree column. 3x squared. 3x squared times 2 is 6x squared. 3x squared times x is 3x to the third power. There's something very meditative about algebraic long division. Anyway, we'd want to subtract what we just wrote from what we have up here. So let's subtract. And these characters cancel out. And then 4x squared minus down that negative 3x. And now we would want to say, hey, how many times does x go into negative 2x squared? Well, it would go negative 2x times negative 2x squared. Now we want to subtract what we have here in orange from what we have up here in teal. So we either put a negative around the whole thing, or we distribute that negative, and that becomes a positive. That becomes a positive. And so this is equal to, the x squared terms cancel out. Negative 3x plus 4x is just going to be a straight up x. Bring times does x go into x. It goes 1 time. Put that in the constant column. 1 times 2 is 2. 1 times x is x. We want to subtract these characters. And we're left with 7 minus... Hey, I have this remainder. I'd have to keep dividing 3x squared by x plus 2 if I really wanted to figure out exactly what this is. Now, if I wanted these expressions to be completely identical, I would put a condition on the domain. You just have to input this part right over here. You'd have to type it in, which I guess isn't the easiest thing to do in the world, but it's worth doing. All right. See you in the next video.
Okay, cool. So let's review. So how many times does it go in 3x? So he puts 3x squared here, and then he multiplies 3x squared with 2. Or am I tripping? No, he does it under here, and then he multiplies 3x squared with 2, and then he puts it beside it. So however long this is going to be, however long it is in here, right? And then we do whatever we can to eliminate these values, adding, subtracting, blah, blah, blah. And we take that difference and put that here. And then he brings this value down. And then we repeat the process. And then we have negative 2x times x is a negative 2x squared. Right? Yeah, negative 2x squared. Negative 2x squared. Wait, hold on. Negative 2x squared. Okay, yeah, it must equal this value. Or it could be equal to the opposite of the value. But you have to make sure that these, at least one of the signs change for at least one of these. But you could do it this way too. But just for safety, just for an extra precaution, just make sure we. Just want to make sure that I'm going to change it here. So, and then we multiply these two together, we get negative 4x, and then we switch the signs over to plus plus, and then we continue the process until we get our remainder, and then this part can leave, and then we can replace this with 5, and then, or whatever the denominator was. Okay, let's go over this. X squared plus 2x plus 4 equal to x plus 3, x squared plus 2x plus 4. Okay, I'm dividing. Maybe divide the question. Polynomial remainder. Is equal to q of x. R is usually constant. Hold on, guys. Be right back. I gotta go to the bathroom. Okay, guys, we're locking in, guys. We're locking in. Gotta get this 1,500. 1,400 plus, actually. That's my goal, my personal goal. But realistic personal goal is 1,400. But let's see if we can get this dub right here. All right, let's see if we can get this super high score. I want a high score. We gotta get it. We gotta do this by studying. No other way than studying. Okay. Anyways, cool. So, blah, blah, blah. Okay, for example, x squared plus 2x plus 4 divided by x plus 3. The highest degree term in the numerator is x squared, and the highest degree term in the denominator is x. The first question we ask is, what is x squared divided by x? Honestly, I don't really like this explanation. I like Sal's explanation better. So let's give it a go here. Let's try it here with 6x cubed. 6x cubed plus 3x squared minus 14x minus 2 divided by 2x plus 1. A little bit dizzy right now, but it should be okay. Oh, hold on. That is a crappy format. Not the right format to divide. Okay, so 2x plus 1. Right, so 3. Go here. Oh, no, 3x squared. Okay, so the 3x squared, and we would put 6x cubed over here, and then pretty sure you guys are pretty confused on what I'm talking about, but you guys can try and take a go at this problem right here. Okay, do the rest. X squared plus 3x squared. Squared. Subtract 0, 0. Okay, and then we bring down negative 14x. Bring down negative 14x. And then negative 14x. Then we do minus 7. Minus 7. Minus 7, and then we do minus 7 to the other side, and then we add, switch these signs together, and then we'll get 3x squared minus 7 times, I think it's times, he did times up here. No, it's plus, sorry. It's going to be plus. I have a remainder of 5, so it's going to be 5 divided by 2x plus 1. So my answer was 3x squared minus 7 plus 5 over 2x plus 1. Alright, yeah, let's see if we, got it. Oh, crap. That was not good. Okay, so the numerator is a third degree polynomial. The denominator is a first degree polynomial. Therefore, the quotient must be a second degree polynomial. To find the first term of the quotient, we must divide the highest degree term of the numerator. Okay, highest term numerator, 6x cubed, by the highest degree term, the denominator is 2x. The first term in the quotient would be 3x squared. Let's check it. Give me your beer back. Okay, I'm back. Sorry, excuse me. So many distractions. Oh my gosh. Okay. Which of the following is equivalent to this? So let's eliminate these two. It's going to be 2 over x plus 2. Okay. Which of the following is equivalent to the expression above? Hello, Blusky. I'm in grade 11, actually. Okay, so immediately I can see I can factor this. Let's do x plus 3, x plus 2. Over x plus 4 times screen is off. Holy crap. Excuse me. Thank you for telling me. Let's see, 2 and 2. Okay, we have x plus 2 x minus 2 over x plus 3. Okay, we can cross these out. And we're going to be left with x plus 2 squared times x minus 2 over x plus 4. Not any of these, unfortunately. It's definitely going to be... No, wait. Oh, wait, no, we can factor x out of this. That's right, that's right. Okay. Excuse me. X plus 2 over x plus 4 times... Okay, factor x out of this. And then we're going to get x plus 4. Cross these out. X plus 3. Cross this out. And then we're going to be left with x squared plus 2x. What's this one? Okay. Which of the following is equivalent to the expression above? Okay, we're going to subtract. So for subtracting, we're going to have to make sure that both of the denominators have a common value. So I'm going to multiply these two together. 2x minus 3. You guys know how to solve this, right? You guys know how to do this? I'm assuming. If you guys don't, then I can do it on this whiteboard here. If you guys want. So, wait, so you want me to do it here, or you want me to... Or you guys know how to do it already? Quick clarification. Okay. Excuse me. Okay, so we have 4 over x plus 1 minus 3, 2x minus 3. Okay? That's a 3. 3, right? So we have to make sure that we both have a common denominator. So we multiply 2x minus 3 on both sides. And then we multiply x plus 1 on both sides. X plus 1. Excuse me. Okay, and then now we're going to be left with, no, simplify it right here. 8x minus 12 a minus, make sure we include that minus there, 3x plus 3 over, crap. Okay, and then over x plus 1, 2x minus 3. Right, so now we can go ahead and simplify this. Minus 3x minus 3. Then we're gonna just bring this down here, over here, and then we can simplify this even further. We're gonna get 5x minus 15 x plus 1 times 2x minus 3. See here, this one seems to be a good contender, but just to make sure, let's factor this out here. So we're gonna be, oh, that's an x, by the way. Sorry. Right? Is that an x? Yeah, it's an x. Okay. All right. Let's go ahead and factor this. We're gonna be left with. Let me just do this in my head real quick. Definitely a 2x squared. Okay, they seem to have factored it out here, so we can definitely factor this out. So that's one of our. I'm definitely looking at this one. Let's just do it to make sure. Okay, minus 3x plus 2x, so it's going to be minus x minus 3. So we're going to be looking at this one. There we go. If you don't understand what I did, make sure to ask me. Definitely going to help some people out there. Just leave this up here for now. Okay, which of the following is equivalent to x squared plus 5x plus 2 divided by x plus 5? Okay, using what we just learned, I'm just gonna draw a line. Okay, hopefully you understand what I just did in that previous question. What we're gonna do here is let's format this to be like this. 5x squared plus 2 divided by x plus 5. Okay, so we're gonna have to find out what makes x times what makes x squared, and obviously that's x, right? X times x is x squared, and then we're gonna write that down right below here when we're dividing polynomials. Okay, and then we also have to multiply this, and we're going to be left with 5x. Oh, that's interesting. Oh, no. Sorry. That is not supposed to be 5x squared. I was like, what the heck? Okay, so let's make our eraser a little bit smaller. There. So, okay. So now we can go ahead. Well, we can't add these together, right? So we have to subtract. Let's change these symbols. Right, before there was a. We didn't get it there. Before it was like this, right? It was adding together, but now we subtract them to eliminate this x squared and this other x squared here, and then we're gonna be left with 0 and 0. All right, and then we're gonna bring this 2 down, and then we're gonna write 2, and then x times what is going to equal 2? To be honest, I actually have. Wait, this actually is so odd. Hold on. It's very, very odd. Remember. Oh, right. It's a remainder. Right, that's all we have left, right? There's nothing left, so it's going to be x. You're right. It's going to be x plus 2 divided by x plus 5. This one. Yeah, this is a little confusing as to why it's so short, but yeah. Seems like you do understand. Great to hear. Okay, let's move on to this next video here.
Which expression is equivalent to the above
Above difference. Okay, I'm gonna do this in my clipboard real quick because this takes so long to do it on the whiteboard. Unless you really want to see it. Okay, I'm gonna go ahead and just do standard procedure. I do not know that method. Oh, wait, I did something wrong. Hold on. I crapped up again. It's minus. This is supposed to be plus. There we go. I crapped up during the process. A little bit of mistake. 38x. There we go. That's much better. No, wait. I did that wrong again. Okay, so it's negative 7x squared minus 32x 32x plus 159. Is that right? That's odd. Okay, yeah, oh, I do notice we can factor that bottom one. I'm gonna restart from square one. We can factor this into 8 and 3, so x plus 8, x minus 3, minus 7, x minus 3. Okay, wait, hold on. X minus 3, so we can get x plus 8 times x minus 3 squared minus x plus 8 minus x minus 3 squared. Three x minus 9 minus x plus 8. 7 times x plus 8 times x plus 3. Oh, wait, hold on. No. No. 7 over x minus 3.
Friends. You get the negative plus sign, but what's neat about this, I'm only, and so what does over this, and actually let me distribute this 50. Probably do all of these steps. I'll try to get to the chase of this minus x, this negative sign, minus 7x, minus minus 56. So it's going to be equal.
Oh, that's where I got it wrong. Yes, it's this weekend. Holy crap, that's such a waste of space. I understand now. That's so unfortunate. Okay, so he factored this bottom one out. It's gonna be x squared. X squared plus 5x minus 24. X squared plus 5x minus 24 is going to be either one of these two. And then he simplifies this, so it's going to be negative 7x plus, no, minus 53. It's going to be this option. I see where I got it wrong. Okay. I need to realize it, because, that's not good. Okay, let's see if we can do this one on my own. If I can do this one on my own. Okay, which of the following is equivalent to 6x squared plus 5x? Okay, let's see. Let's see what we can do here. So which of the following is equivalent? So this is the exact same as this. Five over x. You can simplify this to 2x, 5x, and then I get 7x. Oh, wait, hold on. Whoops. Whoopsie daisies. It was a division problem. Ah, that was so weird. I'm actually weird. Okay. Alright, here we go. 6x squared plus 2x subtract, you get 3x. So, is that right? 2x. 6x plus 2x, and subtract. And then we would get 3x for the remainder. Two x. Oh crap! I'm out of lead. Dude, this thing keeps running out of lead. Okay. Minus 1 over 3x plus 1. I'm looking at that last option here, but I'm gonna do my work just to make sure. Okay, and then plus 1. Yeah. Oh wait, hold on. Yes. This is gonna be our last option here. There we go. Cool. Which of the following expressions is equivalent to dividing that? Go ahead and grab a new piece of paper. Okay, let's go ahead and divide this. Okay, so we got 49r plus 14 divided by 42r plus 42. Okay, so which of the following is equivalent? Let's take a look here. I think I know what they did. Okay, so instead of actually dividing it, we can factor 7 here. Factor 7, and then, oh crap, I think my light just broke. Oh, it didn't break. Okay, so let's factor 7 out here. And we get 7r, or 7 times 7r plus 14 divided by, and then we can take 7. No, if we take 42 out. 42 divided by 7 is what? 6. Okay, right? Let's take 6 out. Let's take 6. Okay, then we'd be left with 7r. Oh, wait, no. I can literally take 14 out, right? No, wait, hold on. 14. 3.5 now. That's 7r plus 2. It's mistaken. Again. Okay, and then we're going to be left with 7r plus 7. That's not right. Obviously can't be C. Let's try this again. 49r plus 42. 40. Wait, hold on. I messed that up. I messed it up. Crap. 49r plus 14. 7 plus 7r plus 2. 7, 42. R plus 1. 1/6. Found my answer. 7r plus 2 over 6r plus 6. Nice. Okay, which expression is equivalent to the given expression for all of x is greater than 1? Okay, which expression is equivalent to the given expression for all x is greater than 1? Well, no other way than to divide it normally. So, let's do that right now. X cubed, we're going to do with 1. X cubed, and then put 9x squared down here. It can't be 9x squared, because we can't do that. Literally just can't do that. X cubed. Oh, right, we can factor that out. I'm literally just left with 9x squared. 1 plus 9x squared over x cubed. But I'm noticing that we can factor x out of the top one here. X cubed. Then we're going to be left with x squared plus 9x over x squared. X squared plus 9x over x squared. And then we can't really do much from there. Plus 9x. Oh, crap. I'm once again at a dead end, fellers. No, that can't be right. I'm at a dead end. 9x squared is my remainder. Nine x squared is my remainder. Yeah. Yeah, that's not gonna work. Why is it this? Why is it this? I don't understand. Those for missing. Okay, I am at a dead end, unfortunately. I need to figure this out. X cubed. X plus 9 divided by x. Why is it x plus 9 divided by x? Oh, they factored x squared. I factored x. Oh, bro. Brev. You're very much right. Left with x plus 9 over x. Oh my gosh, I literally did that. But I factored x. Are you actually kidding me? I factored only x instead of x squared. Dude, please, people, get your sleep. Don't be like me. Okay, which of the following is equivalent to the given expression? Okay. Let's see. Ugh. Okay. Over B times C over 1. No. 1 over C times A times C over B. Okay, I'm gonna cancel these out. I'm gonna be left with A squared over B squared. Nice. Okay, which expression is equivalent to the difference? The difference. Well, I mean, look, well, thank you for giving me the common denominator. All we have to do is just simplify the top part. So we just do 5m squared plus, or subtract these two together, and we'll get plus 5m. So 5m squared plus 5m over 2m minus 9. Double check. Yes. Okay. For z is not equal to 0, which of the following expressions is equivalent to negative 50z squared plus 35z over negative 45z squared plus 40z? Okay, which of the following expressions is equivalent? Okay, let's go ahead and factor these out like I didn't do in the previous question. Let's do negative 5z. We'll be left with 10z plus 7, and then divided by, and then we can factor 5 as well. Let's do now this one should be a minus since I did that negative right there. Let's do negative 5. Let's take out negative 5z again, and then we're gonna be left with z plus 8. Okay, and then we cross these out, and then we're going to be left with 10z minus 7 over x plus 8. Or we can just do the complete opposite of that. Negative 10z minus 7 over... Why the hell did I write x? Should be, what the hell? I'm actually tripping, guys. 9z plus 8. There. 9z. I'm actually so tripping right now. Okay, so negative z minus 8 and negative 10z plus 7. Right now? 10z minus 7. Minus plus. Minus plus. Result of a sign error. Oh, wow. Ah, crap. On the third question, too. That's disappointing. Oh, I forgot to switch that sign. My bad, guys. My bad. So this is a minus plus, and then minus plus. That's so unfortunate, guys. It's just, oh my gosh. Okay, no, it's not the same one. Pretty sure I did do this one, though, right? No, I didn't. Okay. Let's do this one again. Or same concept, just hopefully not the same mistakes. Okay, what is divisible by this? I can do 7, right? 7, 4, 7, 8? Yeah, I can do 7. Let's factor 7y here. 8y minus 4. Oh, I can factor even more. Oh, I can factor literally 28. It's nice. And then we're going to be left with y minus 1. Y minus 1 over 35y plus 21. And it's only y here. I'm at a dead end. Oh no, 7. I'm so stupid. So stupid. So stupid. What the freak, guys? 9, 3. No, I think it's 7 again. Yeah, it's 7y. And then 5y plus 3. Okay, and then we're gonna be left with this. We're going to be left with 4y minus 4 over 5y plus 3. That's right? No? 22. Oh, wait, no, hold on. 8. 8y minus 4. There we go. 8y minus 4, 5y plus 3. Okay, which of the following expressions is equivalent to this? Now, this is like a whole lot of mumbo jumbo. Let's write it in a more readable form. Multiply with 2x plus y. It's gonna be 1. It's just gonna be 1. Right? Oh, wait, I have to. Oh, wait, it's another flip. So it's gonna be x plus y. So it's gonna be. That's so unfortunate. Yeah, it's this one. Start over. Starting over. Okay, which of the following expressions is equivalent to 8p plus 8 divided by negative 32p plus 4? Let's go ahead and factor 8p over 1, or p plus 1, and then factor 4. Let's do it. 4 negative 8p plus 1. Okay, and then we're going to be left with 2p plus 2 over negative 8p plus 1. So 2p plus 2 over negative 8p plus 1. Nice. Okay, which of the following expressions is equivalent to that? Okay, let's put it out in a more readable form. So we're going to do negative 24. So first off, let's actually factor that bottom one here. Looking at that bottom one. No. Can we factor? Yeah, we can factor it. Yeah, we can factor it. So let's go ahead and factor 3 out of that bottom one. And we're going to get negative 8z minus... no, we're going to factor 8. Sorry, excuse me. Negative 3 minus 1. And then on top is going to be 72. Then all we have to do is divide 72 by 8. And then we're going to get 9. So we're going to do, we're going to have 9 over negative 3z minus 1. So 9 over negative 3z minus 1. Okay, which of the following expressions is equivalent to 9n over 45n plus 9? 9n over 45n plus 9. Yeah, I can see that we can factor that bottom one right there. So let's go ahead and factor that. 5n plus 1 over 9n. And then we can do, yeah, we can eliminate these, and we're going to have n over 5n plus 1. Okay, here's another one. So we're going to have a over b times 1 over c plus here d over 1 times f over e. Right, and then we're going to be left with a over bc plus df over e. So we're looking for over bc plus df over e. Hooray! So much more to go. Okay, the function h is defined. What is the value of h of 3? If I just had these easy questions. Okay. They're definitely gonna be asking these on the SAT. But in real life, what we would do is we would copy this Too bad you can't copy and paste. So x squared plus 3x plus 1. X plus 1. Okay, what is 3? Let's go ahead and check it out. It's 19. It's 19. Okay, what is the value of g of -6? Okay, so we're going to have -2 minus 12, we're going to have -14. Okay, value of f of -3. So let's, 3 cubed is 27, right? Now -27 minus 6. -27 minus 6 plus 7. So -27 minus 6 is just -33. Plus 7 is -26. Function f is defined. What is the value of... it's going to be 3. Okay, which of the following correctly gives r in terms of p? So, good old days, guys. We can... got about 30 minutes of study time here, and then before I end the stream, I'm gonna make a little bit of a stretch. Isolating quantities. So, correctly gives r in terms of p. In terms of p, so we must isolate p, right? So let's go ahead. Fairly easy. I don't know why it's so easy. P plus r is equal to 16 in terms of p. So r, oh wait, no, we need to isolate r, sorry. So 16 minus p. What the heck? Why is this so easy? Hold up, guys. Why is it so easy? Okay, so if 2a plus b is equal to 9, which of the following correctly expresses a in terms of b? Correctly expresses a in terms of b. Okay, so let's subtract. We're gonna definitely have a 9 minus b, 9 minus b, and then looking at this one here. Okay, which of the following expressions is equivalent to y? So let's go ahead. We're gonna have a -3x. We're definitely gonna have a -3x somewhere like this. Right, we're gonna have -3x plus 7, and then we're gonna divide 4. So we're gonna divide 4. And I'm looking at this one right here. Here's the following correctly expresses O in terms of P. So let's go ahead and multiply. I think I have to do this one on paper here. 24 O plus P is equal to 5. 24 is equal to 5O plus 5P. And then expresses O, right? So we're going to do 24 minus 5P is equal to 5O. And then we divide 5 on both sides. And then we're going to get 24 over 5 minus P is equal to O. 24 over 5 minus P is equal to O. Fairly easy. Breeze. It's a breeze, guys. What are the solutions to the given equations? Right. Okay. Right. Okay, so let's go ahead and isolate the k here. So I'm going to have 121k squared is equal to -100. Let's square root of both sides, and then we're going to be left with wait, no, you can't do that. No, you can't do that. No. Solving quadratic equation. Okay, I think I'm going to have to go ahead and actually go back here.
And the right-hand side is 70 squared is equal to 36. That something could be the 5, but -6, and there you're going to get the exact same result, because -6 squared is...
Okay, I get that. I do get it. I get that. The zero product property.
Let's say that we've got the equation 2x minus 1 times x plus 4 is equal to 0. Pause this video and see if you can figure out the x values that would satisfy this equation, or essentially our...
So, does he use multiple examples? I think he's doing multiple examples. So the values would be -4 and 1/2. -4 and 1/2. Right. -4 and 1/2. So it should be -4 and 1/2. There we go. There's another example here.
x values, does f of x equal 0? That's what people are really...
In reality, we can just plug this in into a Desmos, and then we would look at our y, see where y is equal to 0, right? I'll show you guys too. This is a good Desmos. This is a good time to use Desmos, but we don't even have to plug it into Desmos. We can just check it out here. So our first value is gonna be 5. And then our second one, f of x is equal to 0 when x is equal to 5, and when x is equal to -2.5. Pretty sure. -2.5. I'm pretty sure it's -2.5. Times 2.5 is... No, I lied. It is 0.25 maybe? Divided by 2.5. I was thinking of dividing, sorry. No, it's gonna be 2 over 5. So 2 divided by 5, sorry, excuse me. 0.4. So it's gonna be 5 and 0.4. Or -2 over 5, same thing. -0.4. Meant to say -0.4. Okay, cool. By factoring.
We're asked to solve for s, and we have s squared numbers a times b, and that they equal to 0. What do we know about either a or b or both of them? Well, at least one of them has to be equal to 0, or both of them have to be equal to 0. So the fact that this number times that number is equal to 0 tells us that either s plus 5 is equal to 0, or, and maybe both of them.
Okay, yeah. I already know what to do from here.
2 can be added. S minus it'll
Okay, so if you got, let's just go through this real quick. So he factors this, right? He gets let's see here. 5s. Right. Whatever 1 and 35 multiplied to 35, or negative 35, and add up to -2. And he gets 5 and 7. And then he puts that in, and then he factors it, and he gets this by using the grouping method. So whatever values make these 0, because we know that it's equal to 0, it's either 7 or -5, which is where he got these values. Nice. Yeah, you can use the quadratic formula as well. I do have it remembered, luckily. Let's go ahead and...
In this video, I'm going to expose you to what is maybe one of at least the top 5 most useful formulas in mathematics. And if you've...
Okay, so it's going to be negative... Mom. Okay, what are all the solutions?
What are
Okay, so what are all the solutions to the equation above? Okay, let's see how we can do this mathematically before we plug it into Desmos. Okay, so we can divide 4 on both sides. 52 divided by 4, we get 13. Okay, and then to get rid of a square root or a square, we can square root both sides, and then we'll get x is equal to square root plus minus the square root of 13. It's gonna be our last option here. Okay, let's look at a harder example. Okay, what are the solutions to the equation above? Okay, so now that we see that it's equal to 5, that is something we need to note. I'm going to go ahead and solve this on my clipboard real quick. X plus 3 times x minus 5 is equal to 5. Okay. Let's take a look here. So what two values always make it equal to 5? 2. I think let's just start plugging values in, to be honest. Let's do 2. Let's try 2. Now 3, 9, 3, negative 15. No, that won't work. It can't be the first one. Negative 3. It can't be the second one. And it can only be the last two options here. Let's see. I want to see how he did it, though. Is equal to 5. So. Oh, I see. Right? No? Negative 3 plus 5, 2, 2, 6, 2, negative 3, no, that won't work. Anyway.
Thứ mấy rồi? Con về xong chào. Ban đi ra cái cửa này con ngồi đây.
Excuse me. Okay, back to. Okay, it's equal to 5. Let's see, what values. Of course, we can plug this into Desmos. Right. Oh, wait, guys, I forgot to show you guys the Desmos solution here. 4x squared squared equal to 42. And then we get 3.24 and negative 3.24. And then if we do the square root of 13, we would get 3.24. Right. 4x squared equal to 52. Sorry. Excuse me. 3.606. Yeah. So I just put it in my calculator, square root 13, and I still got that same exact value. Okay, let's go ahead and move on to this one right here. Okay. Okay, let's go ahead and factor this out. Plus 3x minus 15. X squared minus 2x minus 15 is equal to 5. Okay. Now what values make this equal to 5? I don't know. Oh, wait, I have a solution. No? No solution. No, won't work. Wait, hold on. I'm thinking of something right now. 2x is equal to 10. And then we can square root this entire equation? No. Plus 2x square root x is equal to plus minus square root 10 plus 2x. Yeah, that doesn't give me the solution though, fortunately. The quadratic formula. Oh my gosh. Okay, yeah. So, cannot forget the quadratic formula. So it's gonna be negative b plus minus b squared minus 4ac divided by 2a. Right, and let's plug this in. So we have negative 2 for our b value plus minus square root of negative 2, square root of negative 2. No, not square root, negative 2 squared minus 4 times 1 times c, which is negative 15. Guys, I can't believe I didn't think of this earlier. Would have been cooked. And then we get that for negative 15. Negative 15 times 4 is 60. So we're going to get minus 60. No, plus 60 actually. Plus 60. My bad, guys. Over 2a. It's going to be 2. So negative 2 plus minus square root of 64 over 2. So we have negative 2 plus minus 8 over 2. So our two solutions are going to be 3. It's going to be 3, right? And negative 5. Did I do something wrong here? Negative b plus minus b squared minus 4ac over 2a. Okay, let's double check. Can you shut up, Ben? 15 is equal to 5. Oh, minus 20. Sorry. Sorry, this should be minus 20 because we subtracted 5. Okay. So it'd be negative 80. So this would be plus 80. So it'd be 84. So we have to square root 84. Excuse me. Let me actually do this again because so our equation is negative x squared minus 2x minus 20. And then we just use our quadratic formula. Negative b, so negative 2 plus minus square root of b squared, 2 squared minus 4 times a, which is 1, times 4 times 4 AC, so 4 times negative 20 over 2A, so 2. Right, and then we have negative 2 plus or minus square root of 4 plus 80 over 2, and then negative 2 plus minus square root of 84 over 2. Pretty sure we can simplify this even further, right? So, let's do...
Không làm nhưng mà phải có từ hùng tính tại đấy.
Excuse me. I'm especially looking at that third option here. Okay, we can... Let's see what we can do. Square root 84. 21. I have to figure out how to simplify square roots. Oh, okay. 21, so I have 21 and 4. 21 square root of 2. 4. Look at this last one here as well. Okay, equal to square root of A times square root of B. Okay, we have 4 and 21. 4 and 21. And we have a perfect square for 4. Perfect square for 4. So square root to 21. Is that right? I don't think that's right.
So 2 is 3 square roots of...
Oh, that's how you do it. Okay. So this is square root of 4 times square root of 21. And then we'll get 2 over square root of 21. 2 times square root of 21. 2 times square root of 21. So we have negative 2 plus minus 2 square root of 21 over 2. Okay, and then we would be left with that's weird. It's definitely one of these two, especially looking at this one here. 4, 5. I think it's the last option here. Yeah, it's our last option. He gets positive 2.
Right over there.
How does he
4
simplify
times
it?
22x. So if you divide each of these by 2, which we are doing right here, it's going to be 1 plus or minus the square root of...
Oh, I see. Okay, so how did he get that negative 2? How did he get that positive 2? How did he get that positive 2? I see. Yeah, well, I got it right anyway, so let's continue on. Okay, let's go ahead and start our practice. What are the solutions to the given equation? Okay, so, of course we're going to plug this into Desmos, but grab the two values, but let's do it the paper method. So negative 121k squared is equal to negative 100. Of course, also equivalent to 121k squared is equal to 100. And then we can square root both sides. Okay? Or no, we can divide it by 100. Ah, okay, so we're going to get k squared k squared is equal to 100 over 121. And then we square root both sides, and then we're going to be left with k is equal to plus minus 100 over 121, plus minus square root of 100 over 121. Let's see what they do here. They simplify it. Let's see. They simplified it. Square root right, so this is also equivalent to k is equal to plus minus 10 over 11. There you go. What are the solutions to the given equation? Okay. There is never going to be 3 values. That is not right. Okay, I'm out of space again. Out of space. Another drawing of mine. There we go. Blank new page. Okay. Let's go ahead and factor this. No, let's do that after. X squared minus 17x plus 55x minus 55 times 17 is 935. Oh, I think it's actually just this one. I don't have to do all that. In the given equation, a is a constant. If the equation has the solutions x is equal to 4 and x is equal to negative 4, what is the value of a? So this... Well, huh? You don't even need to. What? No, that's not what we're solving, Brian. We're solving for what values equal the equal to whatever value is that, but I think you missed it. In the given equation, a is a constant. If the equation has the solutions x is equal to 4 and x is equal to negative 4, what is the value of a? So this one definitely correlates to this one, and this one correlates to this one. So a must equal 8 because 2 times 4 is 8, and 8 minus 8 is equal to 0. So this one must be. Okay, what are the solutions to the given equation? Okay, let's go ahead and put this on our clipboard. I'm gonna actually start isolating immediately. Okay, and then I'm going to divide negative 50 on both sides. Negative 50. And then we're going to get 32 over 50 is equal to x squared. And let's square root both of these real quick. I'm going to get a plus minus value. So x is equal to plus minus square root of 5. No, 8. Right? 5? No. It's going to be 5. 4 over 5. 8. No, it's not right. I'm stupid. $16. Okay, so it seems to be 2. So square root of 16 over 25. So I know it's this one, but no, it's not. This is a positive and negative value of x squared. Huh. Interesting. There's the solution. Swear I did this right. Right, square rooted both sides. No, divided by negative 50. Square root 32 over 50. Let me try doing that on my calculator. Square root 32 over 50. Oh, I got 4 over 5. Oh. So it's actually equal to plus minus 4 over 5. So it's this one. I need to understand why. I just plugged into my calculator and I got 4 over 5, and that makes okay, and then that corresponds to this answer. But I need to know why. I need to know how to solve this. 4 over 5. 8. How do they get this solution? How do you get the square root of a fraction? Let's look it up. Fraction. Oh, I see. Oh, I see now. Okay. Yeah, this is so tedious. This is why I should just plug it into Desmos, to be honest. Okay, let's go grab our perfect squares. We're gonna get 2 times square root of 8 and 10, 5, no, 8, 5, no, 12, no, 2, 25, 2 and 25. So 2 and 25, we have our 25 square root 2, and then we have 5. And then plus minus. Four over 5. That's so weird. Hey, then this one must be 4. This one must be 4. It would have to be the square root of 4. What? Square root of 4 times square root of 8. 4. What?
Are you struggling in your calculus class? Do you have a hard time understanding your instructor? Do you wish
is 2. So that's 2 examples. So one where it's already perfect squares and one when you had to reduce. Okay?
Oh, we have to reduce. Oh, I see. Oh, okay, so I already reduced that one. And then 8 and 4, no, 2, 4 and 4. So we have 2 square root 2 over 25. 2, 25. 2, 25. Oh, what the freak? There's no values that multiply to 25 except 5. I'm pretty sure. Guys, I'm tweaking right now. I'm genuinely tweaking right now. Oh, it's already a perfect square. The square root of 25 is equal to 5. So now we get 2 times square root of 2. What? Oh, the square root of 2 is 1. No, it's not 1. I'm so flippin' stupid, guys. Ah. Oh my gosh. Oh my gosh. The square root of 16 is 4. What am I doing, guys? What in the world am I actually doing? Okay, I get it now. Okay, I just have to make sure that I have to do that. Okay, let's go ahead and try that again. I won't be able to finish until tomorrow, and then we can do the harder problems. Near quadratic. Let's do that again. Let's do it again. Okay. What is the value of negative a minus b? Okay. So our two x solutions would be x is equal to negative 4, and x is equal to, let x is equal to a and x equal to b be unique solutions to the given equation. Okay. So our other x value would be 3 over 2. 3 over 2, if I'm correct. Yeah, 3 over 2, 3 over 2. Okay, and then we do negative 3 over 2 plus 4, and then we're going to get 2 and 1/2, so we're going to get 5 over 2. So 5/2. How many distinct real solutions does the given equation have? This one seems to have 2 here. What are the solutions to the given equation? Okay, so let's go ahead and do the exact same thing we did last time. Okay, and then we divide negative 81 on both sides, and then we'll get 11 over 81. Then we square root both sides, and then we'll get square root of 11 over 88. X squared is equal to plus minus square root of 11 over 88. Oh, 81, excuse me. I'm looking at that one, but why is it not the entire fraction? That's odd. Shouldn't it be the entire fraction? I think that's right. No. Oh, it's this one. Oh, I see. I understand. Okay, I have to. Oh my gosh. Okay, in the given equation, m is a constant. If the equation has the solutions x is equal to, whoa, too long. Okay, oh, it's 9:11. Crap. Okay, we gotta finish this and we gotta go to bed. I gotta go to bed. Okay, let's finish this up. Okay, in the given equation, m is a constant. If the equation has the solutions x is equal to -5/2 and x is equal to 3/2, what is the value of m? Okay, so our first solution would be x is equal to -5/2. So then this would be 3/2. This is the oh no, the value of m. Okay, so 3/2 would equal -m times is equal to 3/2. No, -m equal to 9/x. -9/x. It's 3/2. 6. It's gonna equal 6. What are the solutions to the given equation? Okay, so we have n squared is equal to 9. And then we square both sides, and n is equal to 3. Or -3 and 3. Okay, but y is equal to u and y is equal to d. Be unique solutions to the given equation. What is the value of u times d? Okay, let's see. We have 1/2 as one of our... No, not... Yeah, 1/2 is one of our solutions. 1/2 and 8. So 1/2 times 8 is 4. And yeah. Okay, if the equation has solutions x is equal to 3 and x is equal to -2, what is the value of a? Excuse me. -2. Four divided by a. -2 is what I got. A -2x. Crap. Oh my gosh, guys. It's 2. Oh my gosh. Practicing it again. What are the solutions to the given equation? So 72 is equal to 2x squared. Divide 2 both sides. You'll get 36 is equal to x squared. Square root both sides. You'll get 6. 6 only. Alright. Holy crap, I'm restarting. Actually, let me solve this before I restart. Plus minus 6. It's this one. Oh my gosh, guys. I forgot. There we go. Okay, here's an easier one. N is equal to -3 and 3. Okay, its solutions is -1/3. It's this one, either this one or this one, and -2/3. -1/3, -2/3. What is a constant? M is a constant. If the equation has the solutions x is equal to -5/2 and x is equal to 3/2, what is the value of m? Okay, -5/2 and 3/2. 3/2 is equal to, oh crap, -9/m. Okay, and then 3/2 m is equal to -9. 3m is equal to -18. M is equal to -6. Okay, I think m is equal to -6 here. 6. Or it might be just 6 actually. Yeah, it's just 6 out of the -6. Excuse me. Okay, what is the solution to the given equation? 121k to okay, power 2. 121. I actually solved this. I solved this just earlier. Okay, let's go ahead and do it again, just for practice. 100, 121 square root. Okay, and then square root k. We'll be left with k is equal to. Let's go ahead and simplify these down further. We get 10 and 11. 10 over 11. Square root of 100 and square root of 11. So we're gonna have 10 over 11 plus minus 10 over 11. So 10 over 11 plus minus. Nice. Okay, just got a couple more, and then we're gonna go to the geometry, which isn't too much. See how much we have left. Oh yeah, okay. So not too much left, and then we get to the harder questions. And then yeah, that's it. And then we're ready to move on to the English section. Alright, yeah, that'll be it for today's stream. That was like, holy crap, the stream quality is absolutely horrid. I've been streaming for about 7 hours. That's kind of insane. It's kind of insane, guys. 7 hours? I've never studied this long in my life, to be honest. Excluding breaks, but stream is lagging up a little bit. Anyways, I do hope you guys enjoy. This is probably not much to enjoy, but this was definitely very helpful for me today. Yeah, so see you guys tomorrow. See you guys in the next one. Adios. Empty this trash bin. Yeah, alright. Adios.